Hello everyone, and thank you for joining us. Welcome to week 4 of Devtoberfest 2025, focused on tooling and frontend. I am your host Amar, and today's session is all about SAP BTP Terraform. We'll be diving into world of infrastructure as a code and exploring the Terraform and the Terraform provider for SAP BTP and Cloud Foundry. I am excited to have our guest speakers Vipin and Stefan with us today. So, without further ado, Stefan, over to you.
Thank you, Amar. Yeah. So, hi, everyone. My name is Stephen Cherian. I work as a development architect at SAP BTP, and I'm also part of the engineering team of SAP BTP Terraform Provider. Over to you, Vipin.
Yeah. Hello, everybody. This is Vipin here. And along with Stephen, I'm also a technical lead. And I work primarily on the Terraform topic as well as the observability topics on the business technology platform. And welcome to this session today, where you get an introduction to Terraform and its automatic setup with SAP BTP. Over to you, Stephen.
Thank you, Vipin. So, let's jump into how we transform clicks to code and help you automate your BTP landscape setup using Terraform. Yeah. So agenda for today here is let's look at how traditionally SAP customers and partners have been managing their BTP landscape. Let us also have a quick look at how infrastructure as code could help improve things over here or optimize things. Then we look at Terraform, a quick intro to Terraform and the Terraform provider for SAP BTP, which is the most important highlight of today's session. Then we also have a demo for you where we show you how you can build a Terraform provider or a Terraform script to automate your landscape setup on SAP BTP. And we also have some bonus topics like how do you automate brownfield scenarios actually, where you already have an existing infrastructure setup on SAP BTP, which you would now like to bring it under Terraform. Yeah. So this is the agenda for today. Really excited to talk to all of you. Now let us move into the first topic to understand, traditionally, how customers and partners have been managing their SAP BTP landscape setup actually. Yeah. So the status quo. In many cases, people have documented in Word documents or wiki pages the setup which they need to do regularly. So whenever they have a new project or a new kind of application they are developing, they kind of have the set of steps which is required to kind of set up their BTP landscape documented in different places like Jira, tickets, wiki pages, and so on. Somebody follows through this whole document, click through the BTP cockpit, and then set things up actually. Yeah. And whenever there is a new project coming in, you have to again go through the same document, click through the same set of steps, and then repeat it again actually for the next project. And this continues and in a cycle. Yeah, I would say. Some folks or some customers would have automated things actually using some kind of scripts, using the BTP CLI, or we also have the BTP APIs, which are well documented in the API Business Hub, and then we make API calls to via tools like Postman or any other kind of REST client, and then using these APIs we do the automation. And then in some cases, we use products like SAP Automation Pilot as well. Yeah. So these are some of the ways in which people who have used scripts would also kind of try to set up their BTP landscape using scripts. Yeah. So now let us see how things can be optimized further actually. Yeah. How things can become more repeatable and so on and so forth actually. Yeah. Now, let us look at what is the overall goal here when we manage our BTP infrastructure. So the most, we need to be very efficient in our approach over here in provisioning our infrastructure in a compliant way. And the second goal would be to kind of, what is the most efficient way to manage your infrastructure in a compliant way? So two kind of overall goals over here. What is the most efficient way to provision your infrastructure, and the second one is to what is the most efficient way to manage your infrastructure in a compliant way. So the compliant is the highlighted topic over here. How do you manage the provisioning and managing of your infrastructure in a compliant way? So let us see how this can be done using infrastructure as code actually. Yeah. So infrastructure as code is the process of provisioning and managing of your infrastructure through code, which we as developers are very familiar with, rather than clicking through the infrastructure or through the UIs. How about writing your infrastructure requirement as code actually? Yeah. So what are the benefits of making it as a code or moving it or kind of managing it as code? It has numerous benefits. First and foremost, of course, once you have it as code, you can automate things actually. You can automate the provisioning of your infrastructure. Once you have it as code, automatically it becomes consistent because it can be repeated. Whenever you have a new project, you can just write the same code, probably parameterize the things which you need, the name of your account, the name of your project, and so on and so forth can be parameterized. And then in a consistent manner, you can repeatedly run the same automated script. You can also scale it if you need to set up tens and twenties or thousands or hundreds of accounts. Actually, you can also scale the scripts to run to automate multiple account landscapes actually. And another advantage which you also get is like you can also version your infrastructure setup because now it is available as code. You can also kind of upload it to any kind of versioning tool like GitHub and so on and so forth. And there is also an option now, since it is in a versioning tool, other developers can also collaborate when you are writing your infrastructure as code. And the last but not the least is like this also provides an opportunity where your infrastructure is well documented in this code. So it becomes really clear and concise for you what kind of changes have gone into infrastructure, who has done it, and so on and so forth, and what are the different configurations which you have already done in your infrastructure. So your code also acts as a documentation which you can refer to in your versioning tool. So see, these are some of the benefits which you get when you decide to move from clicks to infrastructure as code. Now, let us look at Terraform, which is one of the most popular or the de facto standard in the market for infrastructure as code. So as I mentioned, Terraform is an infrastructure as code tool, and it helps you define, provision, and manage both cloud as well as on-premise infrastructure. It comes from this company called HashiCorp, and yeah, you can use it for setting up of your infrastructure. It also has a unique benefit that it also has allows you to store the state of your infrastructure setup in a state file, which you can store in some kind of a state backend actually, where you can securely store it and then you can use it for future enhancements to your infrastructure. So it becomes a snapshot of the current state of your infrastructure setup, which is stored in a state file, which I should say, like as a best practice, you should ensure that since this state file also contains sensitive information, it should be securely stored in a secure backend actually. And moving on, let us understand how Terraform works actually. Yeah? So what are the different steps which a Terraform script follows to set up your infrastructure? So looking back, we had a look at what is infrastructure as code. We also had an introduction to Terraform. Now let us try to understand how Terraform works actually. Yeah. So Terraform uses plugins actually. There are different plugins for different infrastructure. For example, if you look at this picture on the right side, there are different kind of hyperscalers or infrastructure providers like AWS, Microsoft Azure, and so on and so forth. Each of them have a Terraform provider associated with it actually. Yeah. So the first step would be to initialize the Terraform provider script. And during this phase, the plugins which are required gets downloaded. So this is defined in your script, what all plugins you would need. And then during the initialization phase of your Terraform script, this plugins gets downloaded. Yeah, we will see this as a part of the demo in later. The next step would be kind of the Terraform planning. What this means is like Terraform gives you a preview of what are the changes it is going to do to the infrastructure. It will also show you that these are the changes it is going to do. This is the current state, and this is what it is going to do when you run the script actually. Yeah. So this is what you would see in a Terraform plan stage. This is also a command in Terraform plan, and then it shows you what are the changes which it is going to do. And the last one is the Terraform apply. This is where the actual Terraform script execution happens actually. So whatever you have defined declaratively in your script would be executed, and then the changes are applied on your infrastructure. So first and foremost, you need to have a Terraform script. We would show in a demo how a typical script looks like. Then you, in your script, you would have your plugins which you would need, which will be matching with your Terraform, the final hyperscaler you are running the Terraform script against mentioned actually, along with their versions. Next, you would run the plan where you would your Terraform would show you what is the current state. For this, it uses the state file, which is available locally, and then it will show you what are the changes which it is going to make to your infrastructure. And when you run the command apply, it would make the plan changes and then configure your Terraform or your BTP landscape to the target state, which is defined in your Terraform script. And as I mentioned, the state file is heavily used over here. So whenever the change is going to be made, it looks at the state file and to see if there are any changes, what is the current state of the infrastructure right now, and then applies the delta actually. And once this delta is applied, that is also saved into the state file so that in future, if you make additional changes to your infrastructure, then it can compare it with the state file. Now the beauty of this is that you can also do a destroy. So there is a command called Terraform destroy. So now you have set up a landscape maybe for some kind of testing purpose or some kind of a demo purpose. Once you have finished your demo or your testing, you would like to kind of take down or destroy this landscape. So there is a single command called as Terraform destroy, which would then kind of release all the resources, delete all the setup or delete all the configurations which have been applied, and then roll back everything and then bring your infrastructure back into the original state actually. Yeah. So destroy is also a really powerful command, which also cleans up all your infrastructure setup and brings it back to the original state. Yeah. So this also is pretty handy when you have want to set up a landscape quickly for some kind of POC purpose. And once you have done the proof of concept, you would like to clean up your resources. Yeah. So this is how Terraform works in a step-by-step manner, starting from initialize till apply, and then finally, when you want to bring down things, you have a destroy command as well. Now, this was a quick intro to Terraform and some of the benefits of Terraform, which made us build a Terraform provider for BTP, are that it has a big ecosystem. There are more than 300,000, 3,000 providers out there for most of the well-known platforms outside, be it Amazon AWS, Microsoft Azure, Google Cloud, and so on and so forth. They already have Terraform providers out there. So there are close to 3,000 Terraform providers out there. So it is the de facto standard. So it has a really big ecosystem. And that is one of the reasons why we also decided to build a Terraform provider for SAP BTP so that we can rely on the big ecosystem out there. And automatically, it also provides the capability to automate the setup of BTP landscapes using the Terraform provider. And manage all the BTP resources using the Terraform provider. And also, you can also govern your landscape setup because not everybody will be able to run the script, only probably the administrators and certain specific developers will be able to run the scripts actually, and whatever changes are going to be made on the landscape is also kind of documented in the script. In the Terraform script, so you know that from the GitHub check-ins, who has done what changes to the script and when it was applied on the platform actually. Yeah. So you can also get a kind of governance for your landscape setup using Terraform provider for SAP BTP. Now, coming to some of the key features of the provider, which is the provider for SAP BTP, is it allows you to manage most or whole of your account setup, be it managing your sub accounts, your directories on BTP, configuring your entitlements, configuring your subscriptions. You can manage your runtimes like Cloud Foundry. You can enable Cloud Foundry runtime, enable Schema runtime, manage the creation and the lifecycle of your service instances, set up your trust, user and role management. All of this is something which you can do with the Terraform provider for BTP. The Terraform provider for BTP is available in the Terraform registry. So when I click on this link, it will take me to the Terraform registry. I have it already open over here. So this is the Terraform registry where you can find the Terraform provider for BTP. We have the latest version 1.16. And you can also find the documentation for the same right here in the registry. And this shows you how you can use this Terraform provider in your script. And it has the complete detailed set of documentation on what are the different resources and the data sources which are available as a part of the Terraform provider for BTP. Now, we didn't stop with the Terraform provider for BTP because we wanted to give complete flexibility to our customer or partner to automate the complete landscape setup for BTP. So we went on to create a Terraform provider for Cloud Foundry. And this Terraform provider for SAP BTP Cloud Foundry was also contributed back to the Cloud Foundry Foundation, and it is now accepted as the official Cloud Foundry Terraform provider, actually. Yeah. And what you can do with this Terraform provider for Cloud Foundry is like you can manage all your Cloud Foundry configuration, like the space configuration, the roles, user and role management, where you want to assign space admin or space user manager roles to your user. Your application lifecycle management, deploying your application either as MTA or using CF deploy, service instance management and binding, and so on and so forth. Actually, whatever you can do with the CF CLI can be done using the Terraform provider for Cloud Foundry as well. And this is also available in the Terraform registry. So if you go to the registry, you can also find the Terraform provider for Cloud Foundry under the Cloud Foundry auth. And then again, this also comes with its own set of documentation. It is also a pretty stable version, released more than a year back. We have the 1.8 version running right now. And we also have the documentation available along with the registry. The reason why we also went for a different Terraform provider is because to have a separation of concern. So we have a Terraform provider for BTP, we have a Terraform provider for Cloud Foundry, and we still didn't stop there. We also have built Terraform provider for SAP Cloud Identity Service, for example, for identity and access management. If you want to configure to user management, group management, schema configuration, application configuration, managing our corporate IDPs, and so on and so forth in the SAP Cloud Identity Service tenant. We also have a Terraform provider for same, which you can use in tandem with the Terraform provider for SAP BTP, so that you can do your configurations of your groups in the Cloud Identity Service. And then if you want to assign groups to your role collections on the BTP side in the cockpit, that can also be done using these two Terraform providers in tandem. So this is currently in a beta version. We recently released it actually, and yeah, in later we also will have sometime in near future we will also have some kind of a GA release. Yeah. We also have a Terraform provider for Cloud Connector. Again, most of the capabilities which you need in the Cloud Connector is also handled over here, like the sub-account configuration, service channels, system mapping, and domain mapping, and so on and so forth. These are all kind of implemented in the Terraform provider. We also have a beta release for this, and we will also plan to have a GA release soon, actually. Yeah. And all of these Terraform providers are available in GitHub under the SAP org, in the public GitHub under the SAP org. You can have a look at the code. You can also feel free to create issues or feature requests when you have specific requests against each of these providers. And all the issues and the discussions are pretty transparent. So feel free to kind of have a look at the Terraform providers. If you want to look at their implementations or raise a feature request, please go to SAP org in GitHub and then have a look, raise an issue actually when you have a feature request. Yeah. We also have a landing page where all of the information which I talked about is available in a single place, actually. So if you come to the, we will share the link with you later as well. So we have a landing page where all the information, all the updates related to the Terraform provider is available. All these Terraform providers and their latest versions and so on and so forth is available. This could be a one-stop place for you to understand all information related to Terraform providers. That's it from my side. With that, now I would like to hand it over to Vipin to take you through a quick demo and then talk about brownfield use cases as well. Over to you, Vipin.
Thank you, Stephen, for that wonderful introduction to Terraform, as well as giving an insight about the different providers that we have. So you've now seen that we have multiple sets of providers, and basically the idea is that we have different providers for the separation of concern and also to try to, let's say, have the end-to-end automation flow for the BTP. Now, what we will do is we'll have a quick demo just to give you an understanding, a preview of how the Terraform provider and the whole Terraform setup works. And for this demo, I'll be going with the Terraform provider for BTP. So, of course, this scenario that I'm going to be doing is the typical scenario where we will be basically creating a sub account and then setting in certain entitlements, and then, of course, enabling the Cloud Foundry runtime environment. So if we were to do that from, let's say, the UI, essentially that flow would be something like, you create a sub account, and then let's just say test demo, and maybe let's say I'm just going to create a region, and I also give it a description. This is a test sub account. And then let's say I go ahead and create the sub account. Of course, it's going to create the sub account. It's going to, well, we have to wait for the sub account to get created. And once that is done, we can, of course, wait for it to onboard. Let's just give it a moment. And what you see in this process is, as Stephen mentioned, right? Traditionally, what happens is you would either have a set of APIs or you would go with ClickOps. And essentially, the idea is when we go with these approaches, one aspect is that these are going to be sequential. And the second thing is, to a certain degree, they are time consuming, and as well as the fact that the user, at the end of the day, the developer or the administrator, have to write their own scripts, right? So here you see that me as a, let's say, an administrator of this global account is going in and sequentially going in and doing the various steps. Now I've created this sub account. The next step is I'm just going and creating the runtime for Cloud Foundry, but essentially you get the gist, right? So it's sequential and you have to wait for each of the steps to happen. Now let's switch over to how this would be done with Terraform, right? So Terraform essentially, as Stephen mentioned, uses a scripting language which is called as a HashiCorp language. And this is basically a declarative language where you, as the user, would describe what you want, and you don't need to worry about how it is created, right? So if we go and see the script, you will see that there is a folder, and for this particular session we have created a set of folders. There are a couple of which all end with a .terraform file, right? So the first file over here is the main.tf file, and what we see over here is that in Terraform there is a concept called as a resource data source. Resources are create and manage the various entities within an infrastructure, and data sources are basically to get details in. So in our case, what's the first thing we need? We need a sub account, right? So what are we doing? We need to create a resource of a sub account. And just like how when we create a sub account, what are the things we give? We give it the name, we give it the region. That's the same thing that we do over here. We essentially give it a name, we give it the region, we give it a subdomain, we give it descriptions, basically everything that we need in order to create our sub account. In addition to that, what we also see is that we have added certain things like labels, which help us to identify what kind of a sub account is this. What's the power with all this, right? The first thing is you identified is that you're describing what you need, and you're not really talking about how it has to be done. This is what I want, this is what I need, and it's basically Terraform's job to get it done. The second interesting aspect is you would see that there are a lot of different configuration parameters we have put over here. For example, let's start with for example, these labels, right, which talk about things like region, department, cost center, and whatever. And what we see here are a set of variables. Essentially, the idea is that you can use these Terraform scripts over different types of sub accounts with different variable values, right? So one script, it's repeatable. You just keep changing the variables and you would go ahead with it. So where are these variables declared? How would I say that these are variables, right? So essentially, if we look at the side over here, there is a file which is basically variables.tf. Now, one aspect with Terraform is that these file names can be anything so long as they end with the .tf extension, right? It really doesn't matter what the file names are, but these are the most common naming conventions that are given so that when people are looking through the script, they know what they are expecting. So for example, if I look at the variables.tf file, what do I see? I see the variable name, in this case, let's say global account. I say what's the description so that it's easy to understand what this variable is about, and also the data type. Now, another interesting thing is this all? No, you can also add validations to it. For example, let's look at this. There's something that says stage, right? And of course, there's a description. It says there's a type, and it also has a default value, right? You would see many of these having default values, which essentially mean that even if these variables aren't filled, it would automatically take these default values. And there are certain validators as well. Now, in this case, it says condition and it gives three options, which essentially means that I can't just simply put any value for the stage. It has to be only dev, test, or prod. Anything other than that, it's going to break. So it's basically, showing you what are the, let's say, the validators that can also be present within the Terraform when you write a script. Now, coming back to our script, what we have done over here is the first thing is we have created the sub account. Now, the next thing we need is, of course, with creation of sub account and anything we need to do inside is we need a set of entitlements, right? And we know that an entitlements are created within the sub account. So the next thing we need to do is we need to assign the entitlements. Now, one very interesting behavior of the way Terraform works is by default, Terraform works or tries to create the resources parallelly. And that's how you could say that it tries to, let's say, save time essentially, right? But there are certain resources that have dependencies to others, right? For example, when we want to set entitlements or when we want to set the Cloud Foundry environment within the sub account, we need to know, and we essentially know that the sub account has to be created first, and only then the entitlements and the Cloud Foundry environment can be created. So if we look at this script, we are essentially using a module, and this module basically is a helper module that creates a lot of different kinds of entitlements that are typically required for a sub account with certain defaults in place. Now, if we look at what's happening here, we see that we have to specify the sub account, right? Obviously, when you want to specify the entitlements for a sub account, you need the sub account, right? But what's the magic here? If you look at what's being done, it says btp subaccount.self.id. And if we look at the resource on top, it says BTP subaccount. That's the kind of the resource which is identified as self and of course the ID. Now, when Terraform sees this, Terraform automatically knows that this module, in order for this module to run, in order for whatever this module does, the resources that needs to be created, it has to first wait for the sub account resource to successfully get completed. Similarly, if I go down, the next thing I need is the Cloud Foundry runtime, right? Here also, if I see what I would see is that it says subaccount.self.id. Essentially, what this means is that even this resource requires, basically you can create the instance within the sub account, and Terraform automatically knows, hey, in order for me to create this resource, the sub account should be successfully created first. So what Terraform would do ultimately is that we see that this resource as well as all the entitlements, what they both need in common is a sub account, which means the way Terraform would execute this is it would first create the sub account, and then after that, sequentially, after once it's created the sub account, it would create the entitlements and the Cloud Foundry environment parallelly. So that's the kind of, you could say, the kind of dependency management or the dependency tree that Terraform is capable of doing. Now, the first thing is that. The next thing is that Terraform works with the concept of plugins, as Stephen mentioned, right? So where do we say that, okay, the Terraform needs to use the BTP provider? So if we go back to the files, we see something that says provider.tf. And if we go into that, we basically have this block which initializes the provider. Now, in this case, we have only one provider, which is the BTP provider. And we are essentially saying what is the name of the provider, what's the version we want to use, and we are basically working with it. Now, typically, most providers would have some sort of initializations required. For example, the BTP provider needs the global account, it needs the username, the password. The username and password are set as part of the environment variables as a best practice. And if you have any sort of, let's say, trust identity or you have your own IDP, you would configure that as well. So where are all these variables? We know that anything with var comes from the variables file. And we also know that these variable files have certain default values. Some of them have default values. But let's say that we want our own values for these variables. Where would we declare those? You would see another file that says .tfvars. In fact, in this whole thing, you would see most of them are .tf except this, which says .tfvars. If I go to my tfvars, I see all the variables I need declared with whatever values they need to be. Right. So now with all these in place, let's try to run the script and see what happens. So the first step I need to do is, now that I'm inside this project, it basically lists all the files. The first step is I need to initialize this, right? So what I would do is I would do Terraform init. And when I do Terraform init, what happens is that it's going to read through all the configuration. In this case, it says that, okay, it needs to download this particular BTP entitlement modules, as well as it needs to install the Terraform BTP provider. So now it goes ahead and it starts installing all the necessary providers, or basically the plugins that's needed. So let's wait for that to happen. Okay, so now you see that it's downloaded and it's installing. The first one is the provider. Now, if you see one thing, I've mentioned 1.15.0, but it's gone ahead and taken 1.15.1. That's basically because of this, which basically says any version of the 1.15 bracket, any patch that's also available is going to be taken. So in this case, it's taken the latest patch that's available for that, the 1.15.1, and then similarly with that, it's installing the other modules as well. Great. So now we see that Terraform has successfully initialized, and what you would see if you look at the folders is that it's created a Terraform folder and a log file. The log file essentially is, versioning the different providers that it's downloaded. And if we go to the log file, if we go to the .terraform file, we see that it's downloaded the modules as well as the basic providers that's needed for running our basic script, right? Okay, so now that that's done, the next step is we basically need to know what Terraform is going to do. And Stephen had talked about the planning phase where Terraform would tell you what it's going to do, right? So the next thing we would do is we would run Terraform plan. And now when we do Terraform plan, what's going to happen underneath is it's basically going to tell me what it wants to do. So if I go and look at what it's summarized for me, you will see from the very beginning, it's creating a couple of stuff. It basically tells that it's going to create a BTP sub account. And anytime I see a plus, it basically means it's adding that and what are all the different values that it's going to be putting. And then after that, it's going to create the Cloud Foundry instance. And at the same time, it's also going to add the different role collection assignments that are needed. And of course, the entitlements as well. So this basically tells us what are the different things that is going to be created. And now let's go ahead and do that. So let's look at what our Terraform script is doing, right? It's got a local name, and the name that we are looking for is essentially from the web. It's coming from here, which is basically the sub account name. And again, that's a variable, which is a sub account name. If we go to the variables, we see that the sub account name is DevTurboFest. So let's do that. Okay. Now let's do the Terraform apply. And now when I do Terraform apply, of course, it's going to again say that this is the operations that it's want to do. And it's also asking me, do you want to proceed? Now, of course, in a pipeline, we would not be waiting or running this in an interactive manner, right? We would essentially tell Terraform to run the whole thing in one go. So rather than me doing this interactively, what I would do on a pipeline would be I would do Terraform apply, and I would do minus auto approve. So this way, but what basically would happen is that Terraform now is going to, rather than ask me, should I proceed? It's just going to go ahead and create. So this is going to take a while. What's happening underneath is it's starting to create the sub account. And we basically get to also know what's happening, what's it doing. So it says still creating. If we go to the UI, let's see what's happening over here. Let's just refresh. Okay, so now basically we need to see one sub account that is getting created. Yeah, you see one that says Developer Fest 2025 Dev. So that's getting processed over there. Let's wait for basically all the entitlements and essentially also create the sub account administrator. So if we see the logs, we see that it's adding the entitlements, it's creating the Cloud Foundry instance, and it also tells you all the different things that's happening in the process. And what we also would see is that it tells you what's going to happen, right? So in this case, it says there are 15 resources that are going to be added, 0 to change and 0 to destroy. So that's essentially how Terraform knows what's being done. And yeah, that's it. We see also it gives you the output for the CF and also the sub account as well. So now let's go back and maybe we can just refresh this again. And yeah, this is the sub account that was created. If we go in, we see that it has created the Cloud Foundry environment as well as all the entitlements that were needed would be present. Now, the biggest advantage what you see with this whole setup is that everything being a variable, I can repeat this whole thing. Let's say I needed another sub account, maybe DevTurboFest 2. I could just change the variables I need and everything would work as it is. Now, let's say that I would like to change something. For example, if I were to go to this particular sub account, I see that there are certain labels, for example, that are present here, and maybe I would like to change one of them or add something else in the labels. So I know this is a resource. It has the different kinds of labels that are present here. Maybe I wanted to add, let's say, one more label. Let's say, I don't know, maybe let's say this is type, right? And I say this is just test. Oops, there's a typo here. Right. Now I've added one more label to my sub account and I want to add this, right? So now I come back here, essentially I do a Terraform plan. Oops, my bad. Okay. Right. So now what happens is that it's again going to refresh the state. Essentially, everything that Terraform stores, it's storing in the state, right? So it's refreshing that state. It's going and looking at all the things that it's created. And what you essentially see here is that it's going through the whole sub account and looking for what are the deltas or changes that I've introduced into this particular script of mine. And what I would see is that there are certain things that's changing. Mainly, if I look at this, essentially what it needs to update is that there's a new label that's present, right? So now if I wanted to do a Terraform apply, again, of course, it's going to go ahead. It's going to tell me these are the changes. And then just a moment. I just do a yes, and it goes ahead and tries to create it. Now, in the meantime, what you also would see is that where the instances, so we know that essentially Terraform goes ahead and stores everything in a central state, right? So where is that central state present? This is called the Terraform TF state. Essentially over here, what happens is that this is where everything that Terraform needs, everything that Terraform stores as a central repository or the central source of truth is this terraform.tf state. And as Stephen had mentioned, this is something where you could have sensitive information in place. So generally, this is stored inside a you could say a secure vault or a secure store. This could be either the HashiCorp vault, or it could be Artifactory, or it could be even the AWS S3, or there are many different kinds of plugins that are available where you would do the secure storage of this Terraform state. Now that we see it, you can see that it's basically changed everything. It's updated whatever was required. And once we go back over here, we also get to see that, let's just refresh again. Yeah, we should see that there's also a new label that's present. So that basically, well, gives you a basic demo, a basic conclusion of how this entire setup would look like. And now the question that could come up is that, okay, this is great. I've written all this beautiful scripts, and it's capable of, well, writing accounts from scratch. But most of us have been using BTP for a while now, and we already have sub-accounts in place. Am I supposed to write these scripts from scratch and then recreate all these sub-accounts? How do I work with my existing sub-accounts? How do I bring that into Terraform management, right? So, well, there is a possibility, there is a way of doing that. What we basically do is Terraform has this inbuilt functionality, which is called as Terraform import. So with Terraform import, what you can do is you can bring existing resources on the infrastructure onto Terraform. In fact, Terraform is also capable of being able to generate this script for you. So whatever you're seeing over here, Terraform out of the box has the capability of generating that for you as well. But the problem is that Terraform isn't domain driven. It doesn't know how a sub account and what are the dependencies a sub account has, essentially how to navigate within the sub account, or what are the dependencies between the things. That is something that Terraform wouldn't know how to navigate, right? So what would happen at the end of the day is you as the administrator would need to run the import command. So what would you do? You would first go, let's say that the first thing I need is I need to bring the sub account into Terraform's purview. I would need to go to the sub account ID, and then I would need to take the sub account ID and then do the import command. Once I've imported the sub account, then I would move in. I would go in and look at my Cloud Foundry. I would take the Cloud Foundry ID service instance and then put that. So you see, this is a very time consuming process where I have to individually go and pull in each of these requirements manually. So I would have to write an import block where each of these are there. And you can imagine with a sub account that has a lot of entitlements and a lot of users and a lot of service instances, this can become a very tedious task. You have to essentially repeat the whole process. And the downside of that is, well, it is very error prone, it's cumbersome and of high effort. The fact that Terraform comes with the standard functionality and it works well is great. But Terraform doesn't have the domain functionality in order to automate this for you. And so that is where we have a solution. Basically, what is the solution is called as the Terraform exporter for BTP. And just like with the Terraform providers, the Terraform exporter for BTP is also a completely open source solution that is released through the Apache license. It's a simple CLI, a BTP CLI, where you point to the sub account and it's basically going to generate the whole script for you for that that particular sub account. In the essence of time, we're not going to show that today, but you're always free to. You should try this out, and you will definitely like it. So one aspect you will see is that it's basically a wrapper around the inbuilt Terraform import function. It's not reinventing the wheel. It's just that it's basically, you could say, guiding Terraform on how it has to navigate the entire sub account and also map the different dependencies that are there. Essentially, end of the day, what happens is that the Terraform import and the Terraform generate is going to build and write all the scripts for you. But there are certain issues. One is dependency management is not something that While importing, it would know because it doesn't know what a structure of sub-account versus, let's say, Cloud Foundry is. The second thing is it's going to hard code a lot of things, but if we want our scripts to be reusable, as you have seen here, we would generally want to go with certain variables, right? So what the exporter does at the end of the day is it's going to basically go through the sub account, it's going to import everything into the state, it's going to generate those scripts as well as also try to create some of the most common variables that are there. One other aspect that we have kept in mind, and this is generally a good practice, is that we would like to manage one sub account with one state. We do not want a teralith, meaning we run one script and we have a huge state that contains information of multiple sub accounts. We don't want that. One, because every time, as you saw it, right, when we do the Terraform plan or when we do a Terraform apply, it's going to take a bunch of time to go through the entire state and refresh everything. So you can imagine if you have multiple sub accounts inside that, the amount of time it's going to take. The other thing would be if for some reason the state were to get corrupted somewhere, yes, you could have a backup, but you do not want to jeopardize your entire setup and affect all the sub accounts. So the idea is that you would split sub accounts into different states. So keeping that in mind, the Terraform exporter is also designed in such a way at one point of time you can import one sub account. You can't just point the Terraform exporter to the global account and expect it to just pull off all the sub accounts inside that. So yeah, there's a bit of, let's say, a bit of effort that's also needed from the administrator's side. One thing to be very importantly considered is yes, the BTP CLI, the Terraform provider exporter, is capable of generating the scripts, but it is an expert tool, right? As you know, with all auto-generated code, you need to also have the knowledge of working with HCL in order to understand what is being generated and what is being written. The second thing is that the Terraform exporter or the Terraform CLI makes the import of the resources easy. It also generates your blueprint, your template of code, but that code is not full and final. You need to put effort in modifying it according to your needs. It's not a 100% out of the box thing that where you can just take that solution and run it and everything is going to work fine. No, it's going to generate most of that code, and well, of course, you need to put a bit of effort from your side to polish it, right? But the most important aspect is it definitely removes a lot of the manual work in at least writing things from scratch. But yes, you from your side, you would still need to work on the refinement aspect. We are bringing in continuous improvements. We are trying to make it more stable, and we are also trying to bring in more and more of the best practices so that you can reduce the amount of refinement that you need to put. But of course, yes, it's basically how it is, right? So that is basically the whole aspect about the Terraform provider, how you would automate the various aspects of BTP, Cloud Foundry, the cloud identity services, as well as Cloud Connector, and also how you would work or manage with the existing Brownfield setups. With that, I would head it over to Amar. Maybe if we have some questions or.
Yeah, thank you. Thank you, Vipin and Stefan. I have some questions from my side as well as community side. So the first question is like, so we have our BTP CLI, right? And we have Terraform. So normally developer gets confused with when to use BTP CLI and when to use Terraform, right? So can you tell me more about that?
Right. So one aspect is that the BTP CLI and the Terraform provider, one thing that you need to keep in mind is both are using the same set of APIs. The difference is that the BTP CLI is primarily designed for an interactive is an interactive tool. Essentially, the BTP CLI is what would be used by the administrators on a day-to-day basis when they want to have an interactive, let's say, setup in setting up or being able to navigate through the sub account in BTP. Stephen, would you like to add anything more?
Not really. So I think so as to add to what Vipin said, probably when you want to run a CI/CD pipeline where you want to kind of set up multiple accounts or regularly set up accounts, clean up. So that is where I think the Terraform provider would come into picture. And BTP CLI is mostly for, as Vipin said, for administrators when you want to interactively do change some configurations and so on and so forth. Yeah.
Okay. So over to that actually, as you said, right? So it comes in CI/CD Terraform. So how we can integrate, right? So integrate this CI/CD with Terraform, right? So where this Terraform comes into picture in CI/CD pipeline.
So you can plug it directly into any kind of GitHub Action, Jenkins, or anything, any kind of CI/CD tooling. Actually, Azure DevOps, any kind of CI/CD tooling, you can integrate the Terraform script. You just need to have the script in GitHub or any kind of versioning tool. The environment where the script is running in the CI/CD container or the image or the Docker container or the VM where the script is running, you just need the Terraform CLI. And that's it actually. Like any other kind of CI/CD pipeline, this can run create your BTP landscape, and then when you want to destroy it, that can also be done actually. Yeah. So same manner in which you set up any kind of CI/CD pipeline, it's the same. Its only thing is like in your environment where the script is running, only the Terraform CLI should be present. That's all. Vipin, you
Okay.
want to add to that? Yeah.
Yeah, no, I think Stephen, you've covered it perfectly. The biggest advantage is that Terraform is a very small binary that is, that can be run almost everywhere. So it's not tightly coupled to any kind of a CI/CD setup, as Stephen mentioned, and it's
Yeah.
very
So
lightweight.
one additional thing which you might need to be aware of is like the state thing, actually. Yeah. So whenever the state gets generated as a part of the CI/CD pipeline, you also need to ensure that the state gets uploaded to a secure storage, like as Vipin mentioned, like an Azure, AWS S3, Artifactory, or any kind of a secure store. At the end of the script run, the state file needs to be uploaded into this storage, actually. Yeah. So this is also one thing which you might need to do as a part of the CI/CD pipeline. Yeah, just to ensure that like the state is not lost. Yeah, at the end of the script execution. Yeah.
Okay, I think I'm done with my questions. So thank you again, Stefan and Vipin, for joining us and for a wonderful session. I hope this session gave everyone clear picture about Terraform and SAP BTP Cloud Foundry and Terraform provider. Just quick reminder for everyone, the validation tutorial related to today's session will be available by end of the day. We will see you again in the next session. Thank you all for being here and have a great day. Bye bye.